don't know how it was because that was
Hmm.
like the only last step left. So I was like, okay, this is obviously the answer for this.
Okay, okay, okay. That's how you do, how you
Yeah.
did that question. Okay. So what is? It's very good. You asked the right question. Actually, last time we discussed that 1 mole of gases are measured in terms of volume, how much
Yeah.
space they occupy. Okay, this is volume. Okay. So 1 mole of gas, and that is measured by its volume. Okay,
Yeah.
and that is called molar volume. But for
Yeah.
gases, you need to define the temperature and pressure also, because if you put a lot of pressure, the volume will come down. If you are using less pressure, the gas will expand. That you know.
Yeah.
Okay. So, okay, gases are measured in terms of volume. That is clear. Volume for 1 mole is known as molar volume. That is clear. But you need to tell also the temperature and pressure. Is it clear? I have written the temperature and pressure. Got it? 0 degree
Yeah.
and 1 bar. Got it? 1 bar is close to 1 atmosphere. That is called standard temperature.
Okay.
You-
I mean, I did try to divide 5.6 by 22 by 7, but I didn't get that 0.25 mole.
Yeah, 5.6 divided by, so what that condition is given. Yeah, I think so. You are not getting 20.25 more. Actually, what may be the reason is earlier they used to take 22.4 liters as the molar one. Getting my point?
Yeah.
So maybe they have given it with respect to the earlier calculation. Try this one. Are you going to get the 6 into 4 is 24?
But then how would we know like to divide by 22 by 4?
Yeah. How will you know? Okay, this is actually now known as NTP condition. Old, old STP. Old value of STP was 22.4 liters. Got it? And how will you know? That's a problem, big problem. But it has a very simple solution. I will tell you. So if the values are in multiples of 4, that means you need to divide it by 22.4. Got it?
If they're in
Are
the
you getting
multiple of
4?
4.
Are you getting a point? Because that they may have given the older values of 22.4. Now it is called as NTP. Nowadays, to avoid confusion, it is known as normal temperature and pressure. But if you are appearing for the NEET and JEE mains, they will give you the latest value.
So the molar volume will be given in the question.
If it is not given, go for the latest one.
Okay.
But if you see the volume in the terms of 4, multiples of 4, take 22.4, means they have still not changed the value question, and they are using it the they have based that question on the older value, because there are some questions in my time when I was preparing, so they were 22.4 we used to take. Okay. Is that clear? So I hope the
Yeah.
confusion is clear. Okay. So this is what we discussed in the last class. Homework, any more doubts?
No.
Okay. And how to, from the empirical formula, how to get the molecular formula? What was the method? Just check it and tell me.
So yeah, empirical formula into n will give the molecular
Yeah,
formula.
empirical formula, you need to multiply the whole number, multiply to the whole number to get the actual molecular formula.
Yeah.
And same thing you can use it for the mass. Got it? The
Okay.
empirical formula mass need to be multiplied with some whole number to get the molecular formula. So get the total mass. Got it?
Okay.
So EF mass into N equal to MF. And they will give you the molecular formula mass. Empirical formula mass you can find out from the formula which is given to you.
Yeah.
Put it, you will get the value of N. Multiply that empirical formula by the 10, you will get the molecular formula. Got it? Is it clear?
Yeah.
Any doubts in this?
No, sir.
Okay, great. So now we need to there is one more method how to get empirical formula. If we have empirical formula, we can multiply it by and we can reach up to the molecular formula. But how to get up to the molecular formula by the elemental mass percentages. You will be given the percentage of all the elements. Okay. And from that you can get the empirical formula, multiply it by n, you will get the molecular formula.
So the sum of the percentages?
Is 100.
Okay. So 100, you have to find the empirical formula.
Yeah, actually, yeah, I will give you one example. This is how they try to do it. So they are going to give you some percentages and all, and you need to work on the percentages, right?
Okay.
There is, for example, there is a compound. The compound contain this is by mass, means out of the total 100 gram, 40 gram, because it is percentage, means 40 gram is carbon, 6.67 grams is
Yeah.
53.33 grams is oxygen. That's assume the total mass to be 100. You can assume it anything, but because it is in percentage, it is easier for us to take the 100. Okay,
Okay.
so whatever the percentages are given, take them as the actual mass. Okay, so mass in grams, which is assumed to be equal to their percentages. That is 40. For hydrogen, it is 6.67. For oxygen, it is 53.3. Is that clear?
Yeah.
From this mass, so take first step is clear. Take the mass as the given percentages of
Yeah.
each element. Now find the moles. What will be the moles of the carbon? Hydrogen, oxygen, you need to take the mass of O, not O2. Okay, and O is how much? 16. Is that clear to you?
Yeah.
Okay. So you will get the value. Some values you will get. What value you are getting over here?
3.34 mole for carbon.
And what value you are getting for oxygen? 16 into 3 is 48. Clear?
Yeah.
Are you getting these values?
Yeah.
Now, because empirical formula, does it give the actual mole or the ratio of moles?
Empirical formula is basically the ratio of moles.
Ratio of moles. So in order to get the ratio of moles, you need to divide each moles with the smallest number of moles and get them converted to whole numbers. Are you getting my point?
Can you repeat?
To get the ratio of moles, simplest ratio of moles. So divide the moles of each quantity by the minimum, moles of each element by the minimum quantity.
So
Minimum,
6.67.
yeah, the minimum is 3.34.
Oh yeah.
Okay, so what I will do, 3.34 divided by. So what we got?
Oh, it will be CH2O.
Yeah. It is the simplest ratio of the number of carbon atom, hydrogen atom, and the oxygen atom, which is CH2.
Okay.
So you will be provided with the mass percentage of the elements. Take them as the mass, divide by the atomic mass of the elements. Then take the simplest molar ratio by dividing each moles with the minimum moles, minimum number of moles. With that, you get the simplest ratio. Even if you don't get the whole numbers, You can multiply, if you are not getting these whole numbers, multiply with some 2 or 3, okay, to get them as whole numbers. Okay,
Okay.
clear? Clear? So, and now they will provide you the molar mass. Molar mass.
We need a whole number for that, right? To multiply it with the empirical formula.
Molar mass of the substance is 180. Or gram per mole. So find the molecular formula. Got it?
Okay.
You have the empirical formula.
Yeah. So the mass of the empirical formula will be 30, right? So
Yes,
180 by
12,
30.
12, 12 into is 14 and 16, 30. So EF mass 30 into N will be equal to 180. N equal to 2.
6. Wait.
No, N equal to 2. Yes, getting the point.
Yeah.
So N if it is equal to, because 30 is
But
there.
180 by 30 is 6, right?
One, no, or maybe I'm making a mistake. Yeah. Actually, I'm having a different question. I'm solving a different question. In my mind, there is some different
Okay.
question. Yeah, you are right. Absolutely correct. So EF mass. So better write it to avoid confusion. Okay. So empirical formula into N equal to molecular mass. Okay. EF mass. Okay. So what is EF mass? 30. You told very correctly into N. I was thinking of the acetic acid. Okay.
Okay.
But I gave the problem for glucose, and this is 180. 3 into 6 and is 6. Yes. So the molecular formula becomes what? C6H12O6. Got it?
Yeah. Glucose.
So that's how we get. Sometimes, so what they will give you? They will give you the elemental percentages, take them mass, convert them to mole, get the simplest ratio of the mole, get the empirical formula, multi get the mass, empirical formula mass, multiply it by n and equate it to molar mass, get the value of n and get the formula. This is the whole step-by-step algorithm for getting the molecular formula of a compound.
Yeah.
Okay. So this I hope is clear to you, right? Sometimes they don't actually give all the detail. They just ask you to find the percentage of water or mass percentage of water, mass percentage of any element. That's it. They ask you to calculate. Okay, that
Okay.
much. Sometimes they don't get it. This is the complete formal way of finding empirical formula.
Okay.
Sometimes they just ask you little bit things like find the percentage, find find the mass percentage in CSU.
So you have to find the mass of the calcium carbonate and then.
Yeah, so I'm just not uh, giving you the complete thing. Mass is not given, total mass is not given, so you can take it to be the molar mass. 1 mole.
Yeah.
Molar mass is how much? That is 48. 48 plus 12, 50, 60, 60 and 40, 100. Molar mass is 100. Got it?
Okay.
Percentage of oxygen. Mass percentage of O.
That's O3, right?
Yeah, I'm asking. I'm writing about the element.
Okay.
So total mass of O that you need to multiply by 3. That is true. Mass of O divided by total mass. How many O you took? 3
And mass of oxygen,
is 16.
yeah,
Yes,
16. And
divided by
100.
into 100 because it is percentage.
Yeah.
Sometimes they give just they ask you the elemental percentage. So it is 48%
48%.
oxygen by mass. Got it?
Yeah.
Let's move on to the concentration terms. Okay. So what do you mean by concentration terms? What do you mean?
Concentrated mean
Hmm, what do you mean by binary solution? There are two things mixed. Okay. Binary solution or mixture.
yeah, one solute and then mul mixed with
Yeah.
the solvent.
So it is basically solute and solvent. Got it?
Yeah.
So now you need to express their percentages. Right?
Yeah.
So how you are going to express their percentages? How you are going to tell how much solute is there, how much solvent is there? Tell me.
By the mass.
There are various concentration terms. This is how you represent them in short form. You will get into the meaning very quickly.
Okay.
Mass by volume, volume by volume, mass by volume, mass by mass percentages. Okay. What is ppm?
So what does parts per million and billion mean?
Parts. Yeah, I will explain. I'm just uh, writing a list of all the concentration terms you are.
Okay.
There is a molarity, which is represented by capital mole, capital M, and molality by small m. Molality, small, molarity, and capital. Is it clear?
Yeah.
There is also a mole fraction. Mole fraction is there, and then you have normality is there. Okay. So we have these many concentration terms, which and these terms will be useful for you in this chapter as well in the next chapter. Next chapter in class 12 also. They will be asked.
Okay.
So common. In 12, they are there in the liquid solution. And in class 11, they are there in the first chapter, some basic concepts of chemistry. Right?
Okay.
So now what you do is, actually all these ways are the to get to tell you what is how much solute is there and how much solvent is there. Numerically, how you express them, these are the ways. Sometimes you take their mass, sometimes you take their volume. Okay, moles, sometimes you measure them in moles. Okay, there are various methods need you are adopting, and these are the list of the names. So what these are? These are basically the terms which are used to express the concentration of solute.
Okay.
Got it? Insolvent. Is it clear?
Yeah.
I hope this is clear to you. Next is what is mass percentage. We can get them. Uh, we can discuss them one by one. So what do you mean by mass percentage? Tell me what could be the definition? How you will define mass percentage of a component?
It's basically the quantity of the like the percentage of the quantity in like the solution or like in the compound of a element.
Is exactly you are expressing the amount of substance. Yes, correct. So basically, it is uh, in 100 gram, how much gram of a particular component is there in 100. That is its mass percentage.
Yeah.
Okay.
Okay.
In total 100 gram, how much mass is there? If you assume the total mixture to be 100 grams. Okay. Component mass percentage of a component in a mixture is the mass of the component. Is it clear?
Yeah.
Okay. So what is the mass of a component, given component in 100 gram? Is that clear? Let's
Yeah.
just.
It's a pass percentage.
So am I audible? Okay. So what is the formula? Suppose if you have a mixture of A and B, what is the mass percentage of A? How to calculate it?
100 minus percent mass percentage of P.
Hmm? Mass, yeah, that is true. Mass percentages of both the component, if you add them together, that is going to be 100 because it is the percentage.
Yeah. So 100 minus percentage of V.
Yeah, 100 minus percentage of V. Yeah. But if you don't have the percentage of D, would you tell me what is the mass percentage of A independently? How can you calculate? So what I'm writing, is it clear or not?
Yeah.
So
But then,
independently, how you are going to calculate?
I mean, we still need to know like what the element is, right?
Pardon?
I mean, we need to know like which element A is to know the mass of A, right?
Yeah, that must be given. Otherwise, you can't sort it out. You need to have the total mass. Okay, total mass of the mixture. So if you need to get the mass percentage of a component, you need to divide the mass of that component by the total mass. Okay,
So
into
the
100.
total mass is 100 grams only, right?
No, it is out of 100. How much will it be? Not necessary that they may give you total mass always 100. If they give you 100, that is straightforward question.
Okay.
If they give you 100, that is direct question. Then whatever it is there in the 100 grams, so you can directly claim them to be the mass percentage. But if
Yeah.
the total mass is not 100, then you need to do it in this way. What the point? Clear or
Okay.
not?
Yeah.
Okay. So the question is, let's say, what is the amount of sugar? Need to be present in 500 gram of total solution. Very basic question. So amount of sugar need to be present in 500 gram of the total solution to make it percentage equal to 25%. So 500 gram is the total mass. Got it?
Yeah.
Mass percentage of sugar is 25%. If a percentage is 25%, actually how much sugar and how much water you need to take? That's what I'm asking.
But it's not talking about water, right?
Yeah, you can. It can talk about the water also. You can do it for the sugar. Subtract it from 500. You will get it for water.
Yeah.
If they ask. Okay. So you are going to apply the same formula. Tell me what you are doing. You can do it very quickly.
You have to take the mass of sugar, then divide it by 500.
What is given? Total solution, total mass
Total
is
mass is given
yes. Okay. And what else is given? Percentage
25 percentage.
is given. So percentage of sugar equal to 25%. Okay. Equal to mass of sugar. that is in grams, divided by total mass in grams. How much is it?
So 25 into 500%. So the 25 is in percentage. So we can write it as 25 by 100, right?
Hmm. Yeah. So what you can do is, it is mass of sugar is how much?
Over there, 100, there it will be divided. So 5 will be left. So
Yeah.
25 percentage into 5.
25 into 5. Yeah. Got it.
Right.
So mass of sugar is 125 gram. And what is the mass of water if they ask?
500 minus 125.
Yeah, 500 minus. So that is going to be 400. 400 minus 25, 370. Okay. How much water need to be added to make it
The
percentage 20%?
grams, right? Not percentage.
Mass of, yeah. I wrote the units wrong. How much water need to be added to decrease the percentage to 20%?
So you want to make the sugar as 20
I want to
grams?
dilute it, yes.
So then 500 minus 20 grams, right?
So water need to be added or sugar need to be added?
And water needs to be added, right? To
Yeah,
reduce
water,
the
because
sugar percentage.
you're decreasing the sugar from 25 to 20.
So 125 is basically 25
Yeah.
percentage, right? So
Yeah. So that
125,
sugar
no.
will remain same because you are
Yeah,
adding water, right?
yeah. Oh, so then we can just substitute over here in the same in the formulas. 20
Hmm.
percentage equals mass and then
Yeah,
by 500
actually,
into 100.
yeah, percentage of sugar is 20%. Okay. And mass of the sugar is remain. It has remained same because both the questions are connected. This is not a new question, just a modification of the above. Do you agree with it?
Yeah,
So what should I write in the mass of sugar? 125
yeah, 125.
as the mass of the sugar. And what is the total mass?
It still will be 500.
Will it be 500 or will it change? Tell me quickly. Will it be 500 because the sugar is same, the percentage has changed. How the percentage has changed? You have added water. If you have added water, the mass will change. Are you getting
Yeah.
the point?
Oh, yeah.
Because if the sugar is same, the denominator must increase so that the percentage should decrease.
Okay.
Okay. So the total mass now is total mass of whom? Total mass of the solution.
Yeah. So basically 125 by 20 into 100.
25 into 100 by 20. 625 grams. So the mass has increased because you have added
Okay.
water.
Yeah.
And we know the sugar has remained same because you are in the question only it is telling that how much amount of water that need to extra water that need to be added to make the percentage of sugar 20%. You know the sugar has is same 125. So what should be the mass of water?
625 minus 125.
It is 500 grams.
Yeah.
What is the amount of water which is added?
125.
Initially it was 375 grams. This was the initial amount of water.
Yeah.
125 grams of water was added. So the questions are very simple. You can just try to solve them. Got it?
Okay.
I hope this is clear to you.
Yes, sir.
Right? This is how you're going to do the calculation. Very simple.
Okay.
But read the data very carefully. Whether it is the mass of the sugar. Normally, what a lot of students make mistake. Why do they make mistake? Because in hurry they don't read it properly. Is it the mass of the sugar? Is it the mass of the water? Is it the mass of the complete solution? Three things you need to segregate in your mind by reading the question carefully. You can do any problem. Okay. Neat and yay, okay. You can see. But if you actually uh, try to do it quickly and just mass, or you get confused and uh, you have some misunderstanding related to the mass of water, mass of solution, or the mass of the sugar, then it will go wrong. Got it?
Yeah.
So now I hope you will be able to do any question related to mass percentage. Okay.
Yeah.
One more question I can take. For example, let's take some compound, oxalic acid. What's the molar mass of oxalic acid?
Okay.
Let's say 22 grams. Leave the molar mass. We are not talking about the mole. I'm just talking about the mass percentage as of now. Okay, later we will require it.
Okay.
And so no need to put the formula also. 22 gram of oxalic acid is present in 500 ml of solution.
So what do we have to find it over here?
You have to find the mass percentage of oxalic acid. Which is the solute?
Solute is oxalic acid only.
Yeah. You have to find the mass percentage of it.
Total mass will be 500 ml.
This is the volume, not the mass. Half liters. The volume of the solution. Is it the mass? How heavy is it? Or just the amount? Volume. What it is? You need to get in the denominator the total mass of the solution. What is the total mass of the solution?
500.
That is ml. For
Yeah.
water, it is water. Whether you take it 500 or 500 ml, it is same because the density of water is 1. Okay, you need to multiply by the density to get the mass. Got it? Getting my point.
So
What is the formula?
500 into the density.
Density equal to mass upon volume. Okay, mass equal to density into volume. Density is how much? 1.1 into volume is how much? 500. Okay.
Okay.
Right. So now I hope into 100 because you're finding the percentage. Now I hope it is clear to you. It is how much?
Yeah.
It is 2. It is 11 into 2 is 22. 20 by 5. Got it? 1.1. So it is 20 by 11 into 2 is 20. 11, 220 by 11 is 20. Okay. And 20 by 5 it is 4%. Any doubts in this?
No.
So if the volume is given, you need to get the total mass by multiplying the total volume with the density
Okay.
of the solution. Is that clear?
Yeah.
Okay. So let me let me finish off this class, and this is same. You can think of from your NCRT, which is given in the last, so you can just try to figure out what is mass by volume percentage, volume by volume percentage. I will give some more questions on mole empirical formula calculation in the assignment, and in the next class we are going to continue with this percentages. Okay, so let me end the class. Okay, bye, take care.
Okay. Thank you.